This video is about slope triangles and really just way too much thinking about slope triangles. And it comes from work from Unit 4, Linear Equations and Linear Systems. Students have started calculating the slope of a line given any 2 points on that line. For example, A at -7, -2, and B at 3, 8. And when they calculate that slope, you can understand the calculation by following the movement of these slope triangles. Now, a slope triangle is a right triangle that's drawn between the 2 points. You can draw that right triangle by moving along the horizontal side and then the vertical side, or moving along the vertical side first and then the horizontal side. Now, these are both drawn from B to A. You can draw 2 more slope triangles from A to B. So move along the vertical side, then the horizontal side, or move along the horizontal side, then the vertical side. So this is one slope triangle, and in that calculation, you're going to move this slope triangle so this vertex ends up at this origin, like this. And so we'll go through these calculations in a moment. Or you can move this slope triangle. So again, this same vertex actually ends up at the origin again. And you can really look at 4 slope triangles. So 2 pairs. This slope triangle is the same as this slope triangle, and this slope triangle is the same as this slope triangle. The difference is the order in moving from A to B in this case, or from B to A in this case. And again, for these two, moving from A to B or B to A. And the difference between these 2 triangles is whether or not you make the calculation of the horizontal side first and then the vertical side. So the horizontal side first and then the vertical side, or the vertical side first and then the horizontal side. So over here, the same difference. Make the calculation of the horizontal side first and then the vertical side, or the vertical side first and then the horizontal side. I said it was way too much thinking, so there you have it. So let's look at this calculation first. So we're going to move from B to A. So B is the starting coordinates. So it starts right here and it moves to A right here. That means we're going to subtract these B coordinates from the A coordinates. You always subtract the starting coordinates away from the ending coordinates. So it's going to be A minus B. We're going to calculate the length of the vertical side first. So that's going to be -2 minus 8. And then the horizontal side, which is -7 minus 3. So if we calculate the vertical length first, that's -2 minus 8. So we're at this -2 right here. And right here, we're going to subtract these 8 units and slide the slope triangle down those 8 units. So we subtracted these 8 units, and now this vertical length is at -10. Now the horizontal length, we're going to subtract these 3 units right here. So we're at -7, -7, and we're going to subtract these 3 units. We're going to move this slope triangle over 3 units. And the slope triangle now ends up at a length along the x-axis at -10. So it's -10 along the y-axis and -10 along the x-axis. So this is now a proportional relationship. This vertex is at the origin, and these coordinates are the lengths of each side. So -10, -10. And so the slope is that -10 divided by -10. They are the lengths. So -10 divided by -10 equals 1. So we slid this triangle down 8 units and over 3 units. So it's -2 minus 8 and -7 minus 3. Now we could look at the other slope triangle and move along the horizontal side first and then the vertical side. So now we're going to look at this slope triangle right here. We're going to move this way along the horizontal side and then calculate the length along the vertical side. So again, we're starting at B, so we're going to subtract these coordinates, but we're going to do the horizontal length first. So it's a -7 minus 3. And then the vertical length, -2 minus 8. So we're at -7 right here. And we're going to slide this over 3 units. We're going to subtract those 3 units. And we're at -2 right here. We're going to slide this down. We're going to subtract these 8 units and slide the slope triangle all the way down to here. So again, this vertex ends up at the origin, and these coordinates are the lengths of these two sides, -10, -10, and that ratio for a proportional relationship is the slope. So we slid the triangle over 3 units and then down 8 units, ended up here. And in the first case, we slid the triangle down 8 units and then over 3 units, and we ended up here. So -3, -8, or -8, -3. Now those triangles were moving from B to A. We could also go from A to B. So A is the starting coordinates, B are the ending coordinates. And so now we're going to subtract these starting coordinates from these ending coordinates. And in this case, we would calculate the vertical length first, then the horizontal length, or we could calculate the horizontal length and then the vertical length. So let's look at this slope triangle first. So again, we're moving from A to B, so we're going to subtract the A coordinates from the B coordinates, and we're going to calculate the horizontal length first. So that's going to be 3 minus a -7. So this 3 minus this -7, and then this 8 minus -2, minus this -2 right here. So we're at 3 units right here, and we're going to take away these 7 units. Well, subtracting a -7 is the same as adding 7. So in effect, we're going to add these 7 units to these 3 units. And we're going to slide the slope triangle to the right. So it slides all the way over here. And now we're at -2 right here. And we're going to subtract those -2 units. So we're at 8 right here. And we're going to subtract these 2 units right here, same as right here. So we're going to slide the slope triangle up 2 units. So subtracting a -2 is the same as adding 2. So this slope triangle now ends up at the origin here, and this vertex here is the coordinates of these lengths. 10 units along the x-axis, 10 units along the y-axis. So it's the ratio, since it's a proportional relationship, it's the ratio of those two lengths, which is 10 over 10. So 10 divided by 10, again, equals the slope of 1. It has to have the same slope. So we slid the slope triangle along the x-axis 7 units, and along the y-axis 2 units. Or we could have slid this slope triangle along the y-axis first, and then the x-axis. So it's this slope triangle right here. So now we're going to move from A to B, but we're going to calculate the vertical length first, which is going to be 8 minus a -2, and subtracting a -2 is the same as adding 2. And then the horizontal length, which is 3 minus a -7, which is the same as 3 plus 7, same as adding 7. So we're going to calculate the vertical length first, and then the horizontal length. So the vertical length first, we're going to subtract these -2 units. We're going to slide this up 2 units. We're going to add 2 units. And now we're going to subtract these 7 units from here to here and add those 7 units here. So we're going to slide the slope triangle over 7 units to right here. So this vertex ends up at the origin. This vertex up here, the coordinates of this point are the lengths of the vertical side and the horizontal side. So it's a +10, a +10, and again, that ratio is the slope. It's 10 over 10, which is equal to 1, because it's now a proportional relationship. So a +2 units, a +7 units, or a +7 units, and then a +2 units. And this was the first pair of slope triangles, the second pair of slope triangles, and they come from this slope triangle here are these 2 slope triangles, and this slope triangle here are these 2 slope triangles. The next part of this would be to write the equation for this line right here. And that's for another video.